Hello, hello everybody, and welcome to episode 4 of How to Do Some Game Development. Scripting for Beginners, episode 4. This is the 4th week. I can't believe how quickly that's gone past. Hopefully my mic level is all good and everyone can hear me. Let me just check all this stuff. Yeah, that looks fairly okay. If you can't hear me, let me know. I've got my chat window open here so that I can read what everyone's writing. As usual, I should introduce myself. I'm Andy, and I am a game developer and community manager at Unit 2 Games. And today we're going to be doing some more game development in Crayta. And so this is Crayta. Crayta is it's a platform where you can make games very easily. You can make games without any coding knowledge. You can make games with lots of coding knowledge and everything in between. You can make games. It's great. But it's more than that because it's a creative sharing platform as well. So you can make kind of whatever you want in terms of virtual worlds and 3D environments. And you can do that with people. So you can see there's another me right there. So there's two of me in this world, but this could equally just be someone that I, want to make a world with. So that's totally doable too. So you can make games, you can make virtual worlds, and you can do it with people. You can make them on your own and then share them with people. You can just run around virtual worlds if you don't want to do any creating. But this stream is about how to get into the coding side of game development. And we started from the very beginning 4 weeks ago. Whoa, all that time ago. We set off on a little journey where we started learning about code. What is code? Why is code? How is code? Well, let's do a little bit of a recap. I like to do a recap at the beginning. I should just do a shout out to some of the people that have joined me. The people that I've seen in the chat. Hey guys, hey everyone, nice to see you. Thanks for joining me again. I see some familiar faces. It's so cool to see the same people joining me week on week because and using the stuff that I'm talking about as well, and that's so exciting. One of the best things to do is either whilst I'm talking pause and then go and do things, or watch the stream and then immediately go and see how you can apply it into some of your creations. And if you're not sure, that's a really good opportunity too, because some of the most juiciest and exciting things happen when you're not quite sure what you're doing or why you're doing it. But like this game, for example, it's technically an obstacle course game, an obby. I started from that template, but I really wasn't, I was thinking, okay, let's make a virtual environment, and let's see where the coding concepts take us, because this is more about coding concepts than actually making a proper full-on game. This is more like, okay, what can we use in game type scenarios to sort of learn and understand things. And as we've gone on, we've developed some kind of odd like puzzler, and I quite like it. Quite like where it's going. So I've built a little bit more of the game world and added a little bit more story element to it. And that's going to pay dividends this week, because we're going to be doing some stuff where we need to, sort of branch out a little bit. Branch out in the jungle. Get it? Do some, more rounded, more wider things. Think about what we're actually making and why we're making it and that kind of thing. Hi, Odyssey. Nice to see you. When is code? When is code? That's a great question. I don't know. The first coder was Ada Lovelace, and she programmed, was it the Babbage machine? Can't remember. Yeah, something like that. It's all theoretical in those days. They didn't necessarily have something to do that with, but they had the ideas to do that. When is code? I don't know. Okay, let's do a little bit of a recap. You're going to have to excuse me. My voice is all over the place today. So there's going to be lots of... I've seen some people elbow coughing. Wakim Samake did an elbow cough. And you're going to be seeing me doing a few coughs here and there. It's okay. It's all part of it. We'll get through it together. You know, we're here together. Right. So last week, well, before last week, we talked about what is code. So we started week 1. What is code? Code is instructions. And interestingly, code is like a halfway house between computers who are super logical and talk in maths and humans who are probably not as logical as computers. You know, some humans are more logical than others, but, you know, in the general scheme of things, I don't think many people are approaching the zeros and ones logic of a computer. So we've got super logical computers talking in maths and humans talking in language. And code is this halfway house between the two, so that humans can talk to computers and give them instructions, tell them what to do. And in games, a game designer or a game coder is someone who's leaving behind instructions for the computer to be able to react to players that are running around the game world. And the more instructions we give the computer, the more things that it can do to react to the player in that game world, the juicier and more alive that environment will feel. So, for example, this game world already has, I mean, Crayta as a standard by default has got a whole bunch of cool stuff that it already does. Things like, you know, the character being able to walk around, being able to jump, being able to walk through different like materials and bump into other types of materials so that they can't pass them. All of that sort of stuff is already inbuilt into Crayta. But what we're doing is we're branching into, you know, what happens if I interact with this light? Can I turn the light on? What happens if I interact with this lever? Can I pull the lever? That kind of stuff, which adds so much drama and excitement to a game world. And I'm going to call them game worlds, but they're just like virtual environments is also another term you could use. It doesn't have to be a game. School's out on what? School's out. The jury's out. School's not out. School's definitely in. The jury's out on what makes a game a game. I have theory, which is a game needs an objective, right? So at the moment, this isn't really a game because what do you do? What's the objective of the game? So there's an interesting thing. Anyway, yeah, where code is instructions we're leaving the computer so that it can react to players in a virtual environment and do cool stuff. Code is that weird language. And then we talked about that, and we talked about how we had to basically, the hard part of coding isn't necessarily the syntax, which is like human language's version of grammar. So human language has grammar where you put the punctuation and spaces and how you form a sentence and a paragraph and all that sort of stuff. In programming, we call that syntax. So there are rules around where to put different things in programming, and that's called syntax. And that's not necessarily the hardest bit. It is tricky, but it's something you kind of learn by doing and you learn by rote. So you develop the syntax, you sort of get to grips with it in different languages, and that changes language to language as well. The more complicated part of learning to program is thinking like a computer, breaking down a problem into super logical steps that a computer can follow. And that part you can use in any language because that's the thought process that goes behind coding. And that's something really worth dabbling in, learning about, especially even if you just want to do game design. Thinking about problems in that way can help when you're talking to your developer. Hey, I want to make a light turn on. Can you do that? Cool. DSG, just wanted to say that I've been trying to get into the game dev for a while now, and I've been watching your scripted series since the first one, and you have been the only one who explains to where I can understand. Thank you. Oh, that's so great. That is awesome. I'm really pleased to hear that I'm accessible to you. That's great. And as usual, if you've got any questions, something's not making sense, please feel free to ask away in the chat during this. You can also sign up to our Discord, discord.gg/Crayta. There's lots of lovely people on there who there's some amazing game developers, but everyone in that community, from complete beginner to super expert, is really lovely and helpful. They all want to make just great things and help each other, and reach up whilst reaching down at the same time. That's what it's all about, isn't it? Standing on each other's shoulders and making some really special things and really cool games. So feel free to sign up to that and like and subscribe the YouTube and the Twitch, because there's constantly tutorials and streams where we talk about how to do things and how to make things in Crayta, and you can apply a lot of this stuff to all sorts of different game engines and stuff like that as well. So it's all useful. It's a great learning platform, Crayta, to develop your understanding of how code works and how to make games and all that stuff. Anyway, we were talking about what we've been talking about, and I talked about instructions. Code is instructions, and then we talked about how in order to do things, we do flowcharts, and we did some diagrams and colored them in pretty colors. We talked about variables and properties and that kind of data, holding data in your program, which is necessary in order for code to work and to run. And then how to change that data, to manipulate that data in code to essentially change the game environment. So for example, a piece of data might be a Boolean, which says whether a light is on or off. And a Boolean expression just means something is only true or false. It's got two possible options with any kind of Boolean data. And so by changing that one thing from true to false, you're turning a light on or off. And if you do that while the game is running in your code, that's what I'm talking about. That's essentially, that's coding, but it's also manipulating data. Behind the scenes, that's all it is. And then it makes colors and lights and special effects and cool stuff. We talked about data. We talked about functions and how to bind functions to other things in the game. And then we started dabbling in directing our logical flow. So we talked about how to use conditional statements to do one thing if a condition is true and something else, and something else if a condition is false. We're using if statements. And last week, we started dabbling in arrays and for loops and scheduling. Okay, cool. Yes. Thank you. Hoffnung's Lichtline Gaming. I know that you've left an easier way to say your name in a comment somewhere. I'm so sorry. Can I call you Hoff? Is that all right? So Hoff says, it is worth mentioning that this game is a remixable game, and it will eventually be on Tutorial Springs. But for now, you can actually remix it. If you go into Crayta, go to Create, go to Remix a Game, and then in here, you search for Scripting for Beginners, and you can create a remix of the very game I'm working in. Now, you won't have this stuff behind here. This is new stuff that I've added since last week. But what I'll do is I'll do some stuff today, and then I'll republish it, and you will have all of the code that I've been dabbling in that we do today. And you can go in here and you can turn it into something far better than I've made. Or you could just rip it all out, start from scratch, but with the same code, or, turn it into whatever you want, really. It's up to you. One sec. Okay, so last week we talked about arrays and we talked about for loops. And we said an array is a group of things. So we had our... where's my drone flying to? Come here, you. Let's just turn on editor rendering settings override. This is a really handy thing. So in the world tab, I've checked this, and it just means it gets rid of all of the funky lights that I've changed. I changed the time of day and I moved the sun around and all that stuff. Chicken this box. You put a chicken in this box and all hell breaks loose. No, if you check this box, then you'll find that it's a lot easier to see what's going on in your game world. And then when you test and run it, test the game, you'll find that it has the lighting that you've set up. It's a really handy thing. Anyway, we were going to look at arrays that we did last time. So we have this trigger here. And on the trigger, I added a cinematic lighting script, which I wrote. And this was cool because it had an array, which is this little thing here. So this is something we've done normally. We've done these properties before. And then we added this other attribute to this property here. And we said this property is an array. And what that means is it's a group of things. And those things are of the type entity. So they have to be things that exist in the game world, or things that I've added to my game world here. And they're anything that I've added to my game world, whether it's a mesh, a voxel mesh, sound, light, effect, whatever, those are all entities that are in my game world. Otherwise, they are just assets in my library. So you can still have arrays of assets and stuff, but they're different from an array of things that are in the game world. So I have an array called brazier, and that has all of these braziers in it. And that was in here. So I created that array, added all of the braziers. And then I wrote a function that we can call ourselves. It's called activate. Oh, it's very quiet. Thank you for letting me know. Let me just turn up this. And then possibly, excuse me, laptop, this. Is that better? Is it too loud now? Am I going into red? No, I am quite quiet because I've got a hoarse throat. Don't worry about being late. There is no late. No, don't worry about it. I'm not worried about it. You haven't missed anything. We're recapping still. It's all good. You're okay. We wrote a function called activate. And in that function, we said if you haven't already activated, so if self.active is nil, as in there's nothing stored in this property here, or in this this property, then, and that was our first thing, that was a conditional, then schedule. So this was where we talked about all of your codes running one step after the other. And if we do self schedule like this, and then a function, we can actually break out from that step-by-step flow into another step-by-step flow. And they will run asynchronously. So they'll run at the same time, not necessarily syncing up in the order that they do things. And so everything after this function here, until this end and the bracket, notice there's an open bracket function and there's an end and a close bracket. So in between there, all of that code runs almost like on a separate thread, on a separate step-by-step. I'm using the term thread. I'm not entirely sure it's actually multi-threading, but it's worth thinking about it as a separate thing, right? So they're running at the same time, and you don't necessarily know when this one over here is doing its thing and when this one over here is doing its thing. And we had to do schedule like this because we wanted to use wait, and wait means that you can hold your code at a certain position, stop it executing for however long you want, and then carry on doing that. Now you can't do that without the schedule, because otherwise it's on the main thread and you'll hang your game up and it won't be able to do anything. So it's actually not allowed. You can't even do a wait without the schedule. It'll throw an error and have a problem. So we did self-schedule, and then we looped through all of our lights and we turned them on one by one, actually 2 by 2, and waited in between each group of 2. So we did 2 lights, wait 0.3 seconds, 2 more lights, wait 0.3 seconds, 2 more lights, wait 0.3 seconds. So last week we were really excited because we were talking about how we can use arrays, which is a group of items, and for loops to loop through all of those items and change their state and do things with them. So this is how you can manage lots of things in your game world without having to write loads and loads of code for each individual thing, or hook up loads of events if you don't want to do that, although that is a way you can do that. That is a way that you can do that. That is a way to manage the architecture there. But this way, we can create a group of things, and it could be 100 braziers, and you could turn them all on in groups of 2. And that's very exciting. Yeah, cool. I'm just reading comments. Yes, much better. Okay, that's great. I'm really pleased. Like trains running next to each other on different tracks. Maybe. Yeah, that is a great analogy. Yeah. So when we do our schedule, so imagine you've got one train and then another train, and they're following each other along. And then you hit schedule, and it's like one train's been diverted, and they're on separate tracks. And you can wave at the passengers on the other train, and it might be going faster than you, so you can wave them as they go past. You don't necessarily know what speed each train is going at. But yeah, you can think about it like trains if you like. It'd help if I drew a diagram as well. I think that's like literally the best way to explain it, and I haven't done that. So maybe we'll do that today at some point. Okay. So, well, this is fun. We've got conditionals, we've got for loops, we've got arrays, which is groups of things. We know how to hook things up. We know how to hook things up. Sorry, I bet you lost me there for a second. My microphone, just making sure this computer doesn't fall asleep because I need it. Yeah, we've got arrays, groups of things we can hook up. We've got, event binding. So we've looked at how we can do event binding in Crayta by doing that. So we can write functions and then we can hook them up to specific events that happen in our game. How exciting. That's so brilliant. Okay. So we've got all of these different things, these concepts floating around our head, and hopefully you're trying to put some of this into practice and having a go with it. And if you're not doing that, give it a whirl. Even if it's just, the very basics of what we're doing here. Add a door, add a switch to open the door, add a lever to unlock the door, and then a switch to open the door only when it's unlocked. And then try doing groups of things and changing their state, like, for example, turning on some lights. Let's give it a run and see where we're at the moment. See what I mean? Where, we were in the rendering settings override and now we're not. Okay, so we can run around here, and we had it so that we can turn these on by interacting with them. Little tiki torches, turn them on. So that was hooked up to our onInteract event. We had this, so I can interact with that, and it will unlock the big door. And then we had this switch pedestal. So I interact with that, and it will open the door when it's unlocked. And then I put some music there. And then if I enter the trigger, it lights this stuff. And we were like, this is cinematic and looking really cool. Notice that the other me is still standing there. And all of this is visible to the other me. This is important for today. What are we doing next? What's today, Andy? You've been talking for half an hour and you haven't even touched on what we're doing today. Today, we are going to start looking at Crayta, by default, is multiplayer, which means that lots of people can play in the same game environment. We can make games together. We can play games together. And today, we are looking at how we can run specific things for specific people, execute specific code for specific players. We're going to do it in a simpler way as I could coherently figure out to start with, because we've got all this schedules and conditionals and stuff, and I just don't want to confuse you if I can help it. But this could get a little bit confusing. So ask questions if you get stuck. And I'll try and keep things as clear as possible. So today, we're going to look at what's going to happen. To start with, we'll keep it as simple as possible. You see this gong here? I put a sundial on it. And what we're going to do is when I interact with the sundial, I'm going to make it daytime. And then what we'll do is when I interact with the sundial, we'll make it daytime only for me. So it won't be daytime for this Andy Sargent Jr. over here. And that can be a fun game mechanic by giving the scene a bit more light. It's quite dark at the moment. I mean, it's light where there's lights, but there's dark patches. But by giving it a lot more light, we might discover some things, some story, right? And so that can be an interesting mechanic to play around with, is light. Just light to show different parts of your game world, bring your players to different areas in your game world so that they can learn more about what's happened, what's going to happen, and think about what the story is here. And to start with, yeah, we're just going to do it so it's daytime, and then we will try and also change the ambience. So we've got nighttime jungle sounds here, nighttime insects and all that kind of thing. So we need to think about how we're going to edit all of that so that in the daytime it sounds like daytime and it feels like daytime, and in the nighttime it feels like nighttime, and only for certain people who are flicking between the different mechanics between the daytime and nighttime. So yeah, let's have a look at how we do that. And essentially the reason we're doing that is because I want to look at server and client relationships, what that all is, how we can use it to make some cool games, to make some interesting mechanics, and by doing that you're also then thinking in the right frame of mind when it comes to making multiplayer games, which is Crayta by default. So I think I'm going to need my trusty pad first of all. Let's get that out. Not that trusty pad, you go away. This trusty pad here, and let's open this to start with. Hopefully that's visible. Yeah, that looks visible. Great. Okay. So let's get a nice color. Where's my swatches? There we go. So yeah, when you play a computer game, PC game, or any kind of computer game really, you're essentially playing, you're kind of thinking that your game exists on your computer. This is your computer and you're playing a game on it. And that's all well and good. We're going to call the computer, in this context, your computer is called a client. So that's your computer. If you're playing on Stadia, which is entirely possible in Crayta, your computer, your client, isn't actually your computer that's in front of you. It's a computer that exists in the cloud. That's your client. The computer that exists in the cloud that's sending you your visual data. Okay? But either way, your client is what you're playing what you're playing your game on. That's, hopefully that makes sense. In multiplayer game, in non-multiplayer gaming, so where things are just, I don't know, single player games or couch co-op games, you will probably only ever have a client, and that's it. There's no like networking or multiplayer stuff, online multiplayer stuff. If ooh, good question. Do the games Exploding Barrels by Russ or Fayfolk Go Boom by AJ on Crayta use the topic we talk about today? They do. They do, because specific users have different experiences in the game. As soon as different users are having slightly different experiences, whether that's in something like Prop Hunt, where some users are hunting and some users are prop, whether that's something like Fayfolk Go Boom, like the game AJ and I made, where some users are barrels, some users are Fayfolk, and some users are hunting the Fayfolk. They're having, different experiences. They're on different teams, and so these concepts still apply. The only games these concepts might not apply so much to are really single player games like Obbies, for example, which is technically what this game is that I'm working on at the moment here, but we're going to make it not like that. But even then, because Crayta is inherently multiplayer with a minimum number of players as 4 in your game world, and I'll show you what I mean by that. If we go in here, we go to game and we go max players, we can reduce this, but we can't go lower than 4, it's still important to kind of know this stuff, because there's always at least going to be 4 possible people playing in your game. So you have to get into your head that your game is multiplayer, whether you want it to be or not, and how you manage that is going to determine what the experience is for those people. If you want your game to be single player puzzle game, you need to consider what happens when 3 other people join. And that is entirely possible. And it can make way for some really cool ideas about single player games with other people coming in and out, and mechanics around that, you know, like, for example, maybe you have to collect a whole bunch of things. Coins. You have to collect coins. Classic mechanic. What if, when people come in, you can drop some coins for them, or you can collect different coins to them, and then, you know, that kind of thing. Why is that coming up? Who knows? So yeah, that's really exciting. Thinking about, yes, it's single player, but what can I do with the fact that it's multiplayer? Even if I keep it really the main mechanic single player, you could have little sub mechanics that are multiplayer that really, yeah, leverage that and just make that a little bit more interesting and a little bit more dynamic. Good question. Do those games have it? Yes, they do. So games, solo games and couch co-op games and those sorts of things run on a client, and they will run on that computer that sits under your desk or in front of you. Multiplayer games will generally have a server as well. So they have the game running over here, and then they have a server as well. And sometimes it can be a bit confusing what this server is all about. So essentially, the server is also running the game that the client is running. And what happens is the client will run a bit of the game, and it will send up player input to the server. The server will do some computation on that input. You know, maybe the player pressed forwards on their controller. That input is sent to the server. The server goes, you pressed forwards. Let me make your player move forwards for you. And then I will communicate the new position of your player back to the client. And so this is our client-server relationship. Essentially, the client is gathering input, and then every now and then it will send that input up to the server. I say every now and then, many, many times every second. Then the server takes that input, runs some computation, and then sends back what's going on in the game. And this is straightforward enough. So your client might run a bit of the game, and then, but whilst your input is going up, it will run a bit of the game so that it's not just waiting for the server to come back. So it'll do some game, run some game there. Then it goes up to the server. The server takes that input, checks what's happened, what time that input was made, where your player is moving to, and then it sends that back, and that updates the client. And generally speaking, that's a really smooth process, and you won't even realize that it's going on. But what's really cool is that by sending it to the server, and the server exists somewhere. So we'll put the server in a little cloud here because it exists somewhere in the internet. This exists in your house. This client exists in your house. There's your house. There's the server. And yeah, your client sends your input up to the server. The server does some computation in the game and then sends the update back to the client. And this happens many, many times a second. But what's really cool about this server is we can also have our other 3 players. 1, 2, 3. And these players here, let's put them in their little boxes. These are also the client. So these are also clients. They are computers in other people's houses. Remember, this is your game in your house. This is your game on your computer in your house, and it's communicating to a server that exists somewhere else in the world. And these are someone else's game on their computer in their house, and they're communicating with the same server. So these ones are also chatting to the server like this. Player input goes from the client to the server, and then the game update goes from the server to the client. So how is this possible? How is this server running all of this computation? It must have crazy computing power. It does. But what's really cool is a server, there's no one sitting at the desk with the server on it trying to play it. So all of these clients have people, humans like you and I, sitting at those computers playing them. And so they've got the graphics going on, they've got the sounds going on, they're immersed in the game, and they've got all of the technology that's in a computer to display those graphics and to play those sounds. A server doesn't have to display those graphics. So the server doesn't necessarily do that. The server is only concerned with things like the physics in the game, the game logic, and that kind of stuff. The client is concerned with gathering player input and displaying things to the players. So we can almost do that. We can almost do this in like a little table over here. We have a client here, and we have a server here, and the client, can we do this? Yeah. Cool. The client has things like graphics, sound, and input. And the server has things like game logic, physics, and matchmaking. Let's do that. Let's put that there. So we've got some slightly different reasons for these two different computers. They're both computers. One is the server, and that's really concerned with sort of the underlying logic of the game, and one is the client, which is really concerned with a bit of underlying logic for the game, because it will need to predict before the server can send back what's happened. The client predicts a little bit, and it goes, oh, you pressed forwards. All right, I'll move you forwards, and I'll also say to the server that you've pressed forwards. And the server then goes, oh, you pressed forwards, I'll move you forwards. Sends that back to the client, and the client goes, cool, I'll just put you back where the server has said you were. Yeah, you're all good. You're about the same position that you were. So it does that kind of conversation. So there's a bit of game logic going on the client, but the server has the final say. And the server kind of decides, nope, they were in this position when they were shot. Which, let's face it, is what multiplayer, the multiplayer thing is important in multiplayer games, is you need to make sure that something's doing something. Let's turn that off. You need to make sure that on the server, the position of the player is accurate when someone, interacts with them. Someone else interacts with them. Otherwise, you'll end up with, differences of opinion on what happened in the game. So the server has the final say. And hopefully this relationship makes sense. We've got a minimum of 4 people in Crayta. Each person playing is playing on Crayta on their computer, and that is sending up their input to the server, which is doing some computation and sending back to the client what's happened in the game. Let's just check. Unai, client, give me God mode. Exactly. Server, nope. Unai is spot on there. I play games that are single player but also have co-op. Pokemon Masters, Genshin Impact, Honkai Impact. Yeah, and so you might find that, different games have different implementations of this, but essentially what I wanted to get across was you have a game, you're playing on your computer, and if it's multiplayer, or has multiplayer aspects. It's talking to a server, and the server is kind of defining this is where they are in relation to what else is going on in the game. And so servers are like really, really powerful, but they don't necessarily have GPUs, because why do they need to display graphics? They don't. But they might have loads and loads of RAM, loads and loads of processing power. Whereas a client will need a GPU to display fancy graphics and shadows and lighting effects and all that funky stuff, as well as a screen and so on. And so they're kind of different. You have them for different reasons. Now, back to Crayta. So what are we going to do to explore this client-server relationship? Well, I did mention it earlier, but what I thought we could do is essentially make it so that we can change the time of day for a single person, depending on what they are up to in the game. At the moment, everything in this game is happening on the client, is happening on the server. So I interacted with this. That happens, the animation plays, and the state of that is set on the server. So if Andy Sergeant 2 over here was to go up to that lever, it would be in exactly the same position as that. I then interacted with this switch pedestal. In fact, let's just do this again, because I meant to talk through that. Just ran away with it. It's like, oh, I'm playing the game. Okay, so I'm running around, and this is on my client, and my client is updating the server with what I'm pressing. And it's, the client's doing a little bit of prediction, and it's saying, oh, he's moved forwards, he's moved left, he's moved right. And it's doing that, and then the server is also computing that and going, yep, that's that position, or it's sending through the position, and yeah, they essentially match up. If I interact with this, that gets sent to the server does the whole, they've interacted with that, change the state of that thing, play an animation, etc., etc. I interact with this, and again, that's sent up to the server. So all of this stuff is happening on the server, which means Andy Sergeant 2 can see it too. All the sounds are happening for Andy Sergeant 2 as well, because the state of the game is being changed for everyone. I walk in here, Andy Sergeant 2 can see the flames. And so this is a multiplayer game, and it's cool because we could be tackling this as a group. If I wanted to, we could make it so that this door only opened for one player, right? So I could run all of this stuff on the client and not tell the server that this stuff is updating. But then when I run through here, fine for me, because it looks cool, but Andy Sergeant 2 just sees someone walk straight through a wall, and that's weird and breaks immersion, and it doesn't look great. So when you're thinking about your game in Crayta, you need to be thinking, what does this look like for the other three people? Even if you're thinking it's a solo experience, is there a way you can design your game so that it takes that into account? Could you make it so that rather than necessarily only having this door open for one, the door opens it for all people, but there's some other thing in here which is only accessible to one person? Or alternatively, could you make it so that everyone has their own entrance? That would be even cooler, right? So rather than just having one entrance that one person can do on their own and everyone can just stand there awkwardly watching them, could you make it so that there's 4 entrances and you could get spawned at one of 4 entrances to this same place? So you have to think about your game design as well as your game logic when it comes to multiplayer games, and use it, like use the fact it's multiplayer to do some cool stuff. Now, when we interact with this sundial, I want it to only turn daytime for the player that's interacted with the sundial. So how do we do that? And that's because I want to make it so that it starts to go into some weird dimension where it's different times of the day for different players. And that's like, ooh, mythical and spooky. It's exciting. Oh, good question. Do servers and clients get updated separately or together? So servers and clients are both running a version of the game. They're running separate versions of the same game. The client takes input, does its computation, but also sends that input to the server. The server has its own version of the game, does some computation based on those inputs, and then updates the client with where everyone should be. So if you've got some lag, which is where the time it takes to send that information to and from the server takes a little bit longer than microseconds, milliseconds, you might find your character jumps around a bit because the server is saying, no, they're there. And your client's saying, okay, I predict you're running forwards. And then the server goes, oh, I got this information 5 seconds ago and moved them there. So, excuse me, if you find that your connection is unstable, maybe you're playing in a tunnel on a train or something, I don't know. You might find your character jumps around a little bit. And that is because the server is saying you're in one place and the client is saying you're somewhere else. That's all. Because they're running separate versions of the game, they're just talking to each other. Good question. Yeah, like in-game updates from game 1.0 to game 2.0. Not sure what you mean by that. Do they get updated together or separately? So, for example, if a new feature comes out, they both would get updated because the new feature might be substantial, right? It might be there's now floors which you can walk on. So they would both get updated with that because the server would need to know that floors is now a thing that can exist. And so would the client. Good question. Yeah, so they do get updated together. There might be some situations where one gets updated and the other one doesn't need to update. Maybe, for example, on the client, if it's something very GPU focused. But generally speaking, if you're going to do something like that, you would do it as a bunch of things all together. Okay. Cool. So, yeah, we're going to do some weird mythical stuff where time is different for different people. You know, position of the sun, position of the earth going around the sun. The sun stays where it is. The earth goes around. Well, it doesn't. I don't know. Anyway, let's go into cosmology. No, let's not do that right now. What we're going to do right now is interact with this sundial, and it's going to run a specific function on just one player. So let's think about how we're going to do this. So normally, when we're writing some code that happens on a particular entity, we want to aim to put that code on the root entity of the thing. So if I was to have lots of gongs, like with sundials on like this, and wherever you see one, you can interact with it and it changes the time of day, then I would probably put the script on the gong because that's the root entity and it can muck around with the sundial there. No, let's just do this. Can we do this with the sundial? Oh, that would be so fun. What if when we interact with it, it sort of rotates to a different time? I think we can do that. We should do that. I've got to make sure that I've got time to do that, but that would be fun. So we're going to put a script on the gong. I'm going to click on this gong. I'm going to do entity add script, new script. And this is going to be called my magic sun script. Magic sun script. I was trying to think of something that was, you know, not really long like I normally do. Magic sun script. Okay, so I've added the script, which is also the same as adding a component. Remember, these are entities. This is an entity component system. Entities have components. This gong has a mesh component. It now also has a magic sun script component. In my magic sun script, I'm going to write a function. My function is going to change the time of day. So here I'm going to put change time of day. How do I do that? Well, let's just do it for everyone to start with, and then we'll look at how to do it for just one person. So to do it for everyone, get world, like this, open, close brackets. If you're not sure how I know to do that, then let's get up some, interesting, some Crayta API documentation. This is like the Bible of everything you can do in Crayta and how to do it. Something like the lighting of the entire world is going to be in the world. You can see in the world part of the documentation, underneath it says functions that affect everything within the current world. How do we get hold of the world, you might ask? That you'll find in globals. You can get hold of the current world using the getWorld function. And you can see that it returns an object, or it returns an entity which is of type world. Get world. So let's use that. So get world will get hold of the world that we are currently in. And what can we do with that? Well, all of the things that we can do with that world, you can find here. You can do things like get all of the users that are in the current world. You can set the voxel properties for a particular voxel. You can spawn things. And you can also change parameters like the start time, the day length, the sun direction, all this cool stuff. So you can change all of that at runtime when your game is running. So your player can do something and you can change the post-process effect if you want to. But what we're going to do is we're going to just change the start time. Now the start time is a number. You can see that because it says number there. And it's a number that's 0 is midnight, 0.5 is midday, and 1 is the next midnight. So it's a number from 0 to 1, and that covers the span of an entire day. And that's quite common in programming, to have a number between 0 and 1, and that be, how the kind of the metric for something. Because you can then if you were to multiply that by 24, you would have what hour of the day it is. So let's say 0.5 times 24 is 12. So that's noon, isn't it? So if you think about a 24-hour clock. Anyway, so the current time of day is 17:57. It's very precise. And what I'm going to do, so it's about 6 p.m. And that's a really nice time of day for lighting because you get this beautiful like sunset. And it's also dark, so if you've got any cool lighting effects, it shows up. But let's turn it to noon, start time. So get world dot start time. So a property here, a parameter. These are things that you can change that the world knows about itself. And you can do that with get world dot and then the name of the parameter. If you want to use one of these things, and notice that these start with a capital letter, these are functions, and you would need to do that with a colon. We've looked at that before. Ah, yeah, UNIF says, since a recent update, they're also accessible hovering the property on the game tab to show how to call that property. And so if I hover start time, get world.start time. Ah, I didn't know that you could do that. Nice spot. Yeah, so if you're not sure, you can use this. Get world.start time. There. Yeah. So there you go. So you don't even need to go. Don't even need to go here. That's a useful document though. Make sure you know about that. Equals 0.5 will change it to noon. Now I've written a function. I'm not calling that function yet. So let's call that function when we interact with the sundial. On interact, what entity do I want to call? I want to call the gong. The script that is on that entity that I want to interact with is the magic sun script, and the event that I want to fire, or the function that I want to execute, which is the same thing in this context, is change time of day. And it's going to change it to noon. Well, we're expecting it to change to noon. Let's find out whether that actually happens. So we need to actually get in there, don't we? Let's open the door. Cool. And then... Hey! It's sun time. Sun time. Daylight. Sun time. Great. Okay, cool. So we've changed the time of day when we've interacted with the sundial. But that's changed it for everyone. So right now, there's someone in this game world. Well, there's not, but imagine if there was someone who was like, I don't know, trying to investigate something cool over here that looked really nice with all the lighting perfect. And then just, it's daylight all of a sudden. So it'd be quite jarring for someone else. And also they wouldn't know, they wouldn't have got this idea that you can interact with sundials and it changes the time of day. This is what I was saying about, think about how the mechanic might affect other people that are playing at the same time. So if we wanted to only run this on one player, we can do it in lots of different ways. And I'll show you the long-winded way. And then if we've got time, I'll show you a shortcut, which I've learned recently, which is pretty cool. So the long-winded way is essentially we want to run this on a particular player. So what we can do is when we run this function, we can check if this is the server or a particular client. And it's as simple as if capital I is capital S server and it's a global, just like get world, which means we don't need any context before it. We can just call this function. And that will return true if this version of the game is running on the server. And it will return false if this version of the game is running on the client. Remember when I said that we have the game running on the client and the game running on the server? Well, if we do if is server, that's this one. If I do is client, that will return true if it's this game. So remember, there's multiple versions of the game. Is client will return true if it's this game running on this client, or if it's this game running on this client, or if it's this game running on this client, or if it's this game running on this client. So it will always return true if it's running on the client. If it's the game that's running on the server, it will return false, which means that in an if statement like that, the code between then and end will only run if this is on a client. So let's check if it's the server. If it's the server, then we don't want to run the change time of day. So we can do a return here. And what that means is it will stop running this function. It'll exit the function. Let's try out that. Let's see what happens now that I've done that. And we'll build this up gradually. So let's unlock the door. Let's interact with this. So nothing's happening now. And that's because that function's getting called only on the server. When you hook something up like this, when you hook something up like this exists on the server and it doesn't exist on the client. To run this on the client, you have to do some special scripting to make it run on the client. That's why we didn't see the world go to daylight when I put this if is server return, because it was saying, oh, we're on the server, exit the function. It never got to this line of code. Hopefully that makes sense. If I have if is client here, I mean, 5 guesses what might happen. Let's have a look just for the proof. So I interact with it and it's daytime. This is because isClient is false, and so this code is not executed. So we know that this change time of day function, because it's hooked up to a binding on the sundial that's on interact, we know that this is only running on the server. So this is always going to be false. So this code here, this return, never gets executed. And so this is pretty much superfluous. It's just not doing anything. And then we are changing it to noon. If we do if is server, that is true, isn't it? Because we're on the server. This function is being executed on the server and only on the server. Remember we said that the player input is sent from the client to the server. We didn't say that the player input is executed, that stuff happens on the client, and then it gets sent to the server. So this never gets run on the client at the moment. Now, if we wanted it to run only on the client, if we wanted this function to run on the client, we could do something like if is server, so that's true, isn't it? Because it's getting called on the server, then self, which refers to this script, Magic Sun script, self, colon, send to all clients. Open bracket, the name of the function that we want to call. So that would be this one. End quotes, end bracket. So now, if is server, now is server should be true because this function is called on the server, then send to all clients, change time of day, return. So ask the client to run this function and exit this function for the server. Remember, here we're just sending an event. We're asking the clients, all of the clients that are connected to the server, to run change time of day. And then we are continuing on our server. The next line of code is return, so exit the function. So it doesn't get to this point on the server. When this function gets called on the client now, because this is firing it on the client, check if we're on the server. Well, we're not, because we're on the client at this point. So that's false, which means this code won't get run, which means we'll get to this point and we'll be able to change the time of day to noon for the client. Let's have a look at that. So I'm going through the same process. Let's open the door. Let's interact with the sundial. Okay, so it's daylight, but it's only daylight on the clients. The server still thinks it's nighttime because that update of the start time only happened on all of the clients that are connected. So it's the same for me and it's the same for Andy Sargent too over there. We're both now in daylight, but we're in daylight on our own computers. Hopefully that makes sense. We can see further proof of this if we want to. If I do a print statement here, capital P print, you can do lowercase p as well. That's fine in Crayta. And sometimes it's quite good to just copy this because it's got the name of the script and it's got the name of the function. And if you're not sure if some code is running on the server or the client, if you do this, print, and then the name of the script and the name of the function, let's test that. Let's open up our console by pressing O on the keyboard. Ignore the errors. Errors, part of it, isn't it? Let's get in there. Let's go and turn on this. Okay, look at this. Look at this situation. We have two prints that popped up here. We've got this server here, Magic Sun script, change time of day. Remember, we asked to print that. Now, what's really cool about a print statement is it will print out where it's running the code as the first thing. So the first time, prints server. Then, straight afterwards, it prints client when it's running on the client. So if you ever get lost and you don't know whether code is executing on the server or the client, just do a print statement. It could be anything. It could be blank, and it will print out whether it's happening on the server or the client. It looks so simple setting up client-server stuff in Crayta that I couldn't believe it when I tried it for the first time. Just write a line and it will change from client to server and vice versa. Yeah, I couldn't believe it either. All of that time writing multiplayer code. There you go. So you don't have to write loads and loads of multiplayer code to get things running on the client or server. You can do send to all clients. But that wasn't the end of it, was it? Because we wanted to only run that bit of code on one client. The client of the player who pressed interact when they looked at the sundial. So for Andy Sergeant 1, Andy Sergeant 2 standing at the top of the steps. You know, that person is just not interacting with the sundial. So it should remain dark for that person. For Andy Sergeant 1, who runs in there and hits that sundial, it should turn to daylight. At the moment, it's still turning to daylight for both of them. So how do we solve that problem? Well, what construct do we already know that can diverge things depending on whether something is true or false? It's another if statement. So what we need to do is only run this code when it's the player who has interacted with the sundial. When we run our interact, when our interact event gets called here on interact, it fires this function. It actually is also sending us the player, the character who did that interact, and we can capture them in this argument so that this function gets called, this function gets executed, and we're actually being sent the player who interacted with this thing. We're being sent the player who fired that function. We can choose to ignore that and not care by leaving this bracket empty like that, or we can put something like player in there, and now we're capturing that person in a variable called player. You can actually call this whatever you want. You could call this gobbledygook if you wanted to. I'm going to call it player because it makes sense, because it's the player. So we can get hold of the player that interacted with it. Now, at this point, remember, we are running this code on a client. So we can get hold of the client that we're currently on. And remember, it runs this on all clients. We can get hold of the client by going, let's get hold of the client and put them in client, a client variable called client. Let's get hold of the client then. So we can do that with get world, get local user. So that is a function that you can run on the world, and that will get hold of whoever is currently, whatever client this is currently playing on. So on server is for everyone and one client is on individual basis. Absolutely. Yeah. So each player of this game has their own client, whether that's you're running EGS or Stadia, you have your own client. The server, there's one server for everyone. And you'll see that when, let's say you had 30 people trying to play this game, there's a cutoff. I think the cutoff is 20. There's a cutoff of 20 people. And once it hits 20, then that server is full, i.e. the load of people that are on that server, that's kind of enough for that server to handle. And a new game world will start up. The same game, but any more people get added to that one. Hopefully that makes sense. So for us, we're just playing around with the idea that there's 4 clients, but there could be up to 20 for this game. And so each player has a client and each game has a server. Each game world has a server. Hopefully that makes sense. Back to what we were doing. We are getting hold of the local user that's running on this client. Now this code will throw an error if we try and run it on a server because there isn't a local user on a server. So we have to make absolutely sure by using things like this that we are only going to be running this on a client. So we use isServer and we return here. We send to all clients at that point, and so we know we're on a client here. We can do something like print username and then client get username gets the display name of, and then because it's a text, we'll just format that. Do we need to do that? I don't know. Let's find out. So let's try that out. Let's just close the console while all those errors are kicking off. It's all right. We're not thinking about that right now. Okay, so let's interact with this. Hey, username supergoose2294, which is my username. So that's working. So we know we can get hold of the particular client. And notice that only came up for me. Well, you probably don't know that, but it only came up for me. That, oh no, that would have come up for everyone. That would have come up for everyone. So how do we test this client and make sure it's this player that's this client? Because that's what we wanted. We only wanted to do that for this particular player. Well, we can do an if client is equal to player colon get user. So the client is a user. Remember, get local user. That gets stored in client. We check the client against whatever user is in control of this player. And one more thing before I explain it. We need to send this player, because we're calling this function again, we need to make sure that we're passing on this player to this function. So we put a comma, player here. So this, a user interacts, or a player interacts with the sundial. This function gets called on the server and sends through the player that interacted with it. We test, are we on the server? We are, because that binding is hooked up on the server. And so this code is run. Send to all clients the name of the function and then any values we need to pass along. So we're passing along the player and return. So we exit the function at this point and this code is not executed on the server. Then this function is called on every single client. So this one, this one, this one, and this one all call change time of day. And they are accepting the argument of player. So the player that interacted with the sundial is sitting in here. We check if we're running on the server. At this point, we're on each of the clients individually. So it's not the server. Get hold of the client we're currently on. Get hold of the user that is playing this game. And store them in a variable called client. And then what we do is we check, is this user that is playing on this client equal to the user that interacted with the sundial? The double equals means, are these the same? A single equals means put this user in this client. Make this client equal to this user. Two equals means, are these things the same? So it's a test rather than an assignment. Then get world.startTime equals 0.5. So set the time of day to 0.5 for just this client, because all of the other clients have different users and this is false for all of the other clients. This is only true for one client. Let's see it work. Let's go down here. So interact with this. That runs on the server. Interact with this. That runs on the server too. Let's go in here. All of this is running on the server, so this is updating for Andy Sargent 2 up there as well. They're watching it. Interact with the sundial. Daytime! But Andy Sargent 2, you can't see because it's on the other screen. Andy Sargent 2, it's still night. But for Andy Sargent 1, it's daytime. So now I can go up here and I can... Oh, wait. What's this? I can see this because it's daylight. And I can see some story over here. Huh. How did I get here? And so on. There's another sundial. What could that do? Should we hook that up to a different time? So we kind of... That works. So that all works. This is only running on one particular client. And what we could do to, you know, complete this script is maybe put a property here for the time of day we want to change it to. Save that. Let's go to our gong. And the time of day for this one was noon, so 0.5. And let's just change this. So we've made a property called time of day, which is now accessible with the editor, which means we can now use that property in our code by referring to it, self.properties.time of day. So wherever this self.properties.time of day is, it gets replaced with whatever I've set in the editor there, which is cool because it means that this is exactly as it was before. But it also means, let's go out of here. Let's go to this sundial. Let's do entity add script. And let's find our magic sun script. And let's change the time of day here. What time of day is 6 o'clock-ish? Let's change that to 0.5 is noon. Let's change it to 0.25, which is a quarter of a day, which is 6 a.m. Let's change it to 0.23. And let's hook up this sundial. So change time of day over here for this specific player to 0.23. So let's go in here. How many times do you want to watch me solve this puzzle? Maybe we'll change it next week and do something else. So change it to noon. Notice though that the sound of the insect is still there. You know, so it still kind of feels like nighttime, which is a bit weird, but could be interesting. And then let's interact with this. Oh, morning. It's a bit dark morning. Let's just make it a bit later morning. Maybe like more like to 8. Yeah, cool. Change time of day. So what else do we need to do really? We kind of need to change the insect sound to maybe a more daytime sound. Nighttime insects. Yeah, we can just change it to that. So in here, we'll also want to change name equals ambient sounds. And the type is an entity. Let's change those ambient sounds. Where are these? Well, we can just search for sound. Okay, so there's actually 2. So this is a good opportunity to use that array thing I talked about last week. Let's make this an array of sounds. And we're checking here, aren't we, that this is the right client. So here we're going to do a for index equals 1 to the number of ambient sounds we have. Hash self.properties .ambient sounds do. Let's make an array as well of ambient sound effects. Time of day, Todd ambient sounds to replace them with. Sound asset. So we've got 2 arrays. Whoa. And we're just going to change the sound asset of one to be the other. I wonder if that's possible. I haven't even considered whether that might not be possible. We'll soon find out. Index dot. Can I do sound asset? Let's find out. Let's find out if that's actually doable. Live on the edge, you know. So we've got 2 arrays, and what I'm going to do is basically take the ambient sounds that exist in my game already, and I'm going to make them the sound asset of a corresponding thing here. It needs to be index. So the first one is the cicadas, and let's use our jungle ambient sound there. Let's find anything else that's a sound going on. Nighttime insects. Yeah. So we need our sundial. Nighttime insects. Here they are. That's an entity. And what sound are we going to replace that with? Let's have the sound of water, maybe. Or birds. You get tropical birds. Yeah. Some of them. Don't know if that'll work. Let's find out. So essentially I'm looping through the ambient sounds that I have in my game world that you can hear already. And I'm just replacing the sound asset with something else. I don't know if it'll work. We'll find out. No. Doesn't work. Yeah, got a bit upset there. Never mind. Worth a try. Bad argument. Who knows? 21. Yeah. I thought we might be able to do that. But I don't think we can. Never mind. Anyway, we're changing the time of day for just one person, and that is pretty much everything I wanted to cover today. The most important thing was about the server and client relationship and making sure that we understand that there's 2 things that are running the same game. One's the client, which is running on the computer in someone's home, and one's the server, which is running in the cloud somewhere, and they talk to each other. We are also kind of exploring the idea of changing the time of day. We can change some of the other world settings too. Remember, we had a look at hovering over these things. So we can change the color grading and the post-processing. So color grading is quite interesting because it just, let's just uncheck that. It changes the display. So you can make things spooky, you can make things alien, you can make things unicorn, and so on. Let's leave that neutral. And you can also do some pretty mad stuff with the post-processing effects. So we've got color grading and post-processing. Halftone, cell shaded. So, thermal picks up other people. Tilt shift makes it blur and seem like it's all a dream. Maybe we can hook that up too. Let's do that. So if we go in here, go on here, we're going to get rid of these things. We are going to do there. Color grading. Was it color grading? Post-processing. Todd post-process. The reason I'm using Todd is because time of day. Type equals process asset. Yeah. Post-process asset. And here we're going to choose tilt shift. And that'll be quite fun because it'll be like it's turned to daylight and it's like, oh, it's a bit bleary. Maybe we could also get some daytime music. Yes. Todd music or Todd sting would be cool. Just a sting rather than a piece of music. Let's do that. Let's now hook those up. So get world dot post process equals self dot properties dot post. Oh, Todd post process. So change the post processing effect for just this user, and let's play a sting for just this user as well. So self get entity play sound. Play sound 2D because it's a piece of music. Self.properties.Todd sting. A sting is just a short piece of music. Doesn't repeat. The idea is that you play it when something happens to emphasize the thing that's just happened. Let's have a look at sting. If we put sting in here. Nope. A bit too fun. I'm more... The other thing we could use, rather than a piece of music like this, is just a chord, crod, on maybe something like this. Yeah, let's do that. And it would be cool to do like a snap sound as well. I wonder if there's a... or a light switch. Switch. I just saw switch as well. Let's just go with the chord for now. Let's play that sound. Oh, we've done that. So that should work. Let's try it out. Yeah. Okay, so that'll work for this one. It won't work for the other one. Any other suggestions? Things that you might like to see? Oh, we've left it on. We've left on the old tilt shift. Let's turn that off. Default? Yeah. Cool. Sound in play. Interesting. Are the torches also turned in client or server? Oh, I've got some questions. So on server is for everyone and one client is on individual basis. Yeah. With this client versus server stuff, can you make it where some things can be interacted by everyone by having it interactive on server, and have other things only interactive on client, so only certain individuals can use the items and not everyone. Yes, that is entirely what I'm talking about, and you can definitely do that. Okay, here's the thing. What could we try here? Maybe one character. Let's make it so that one character can change the time of day. So one character can interact with the gong and one character can open the door. How would we do that? Let's sack off this sound issue I'm having. Oh, it's because that. No, is it because that? I don't know. It should work. I don't know. Oh, we could call it on the player, and it would definitely work. I'll just try this, but yeah, exactly what you're saying. We'll have a look at that. What we'll do is we'll make it so that we almost have roles that get assigned automatically when we jump in. So how would we do that? Well, it's a little bit more complicated. Let's break the problem down. Let's do a flowchart. Okay. Let's solve this problem visually first. Right. So let's turn the pad on. Come on. Okay. Great question. I love it. Unif says, are the torches also turned on in client or in server? Are the torches turned on in client or in server? Their state is turned on in the client. The graphical representation of a torch being on is done. Their state is changed on the server. So the server turns that torch on or off at the moment. Showing the fire and the light, that's all handled on the client's computer. So drawing the graphics on the screen, client. Handling the fact that the light is on or off, server. Hopefully that makes sense. Okay. Multiplayer puzzle. So when a user logs in, when a game starts, it could just be one person starting a game. Once one person is playing a game, that means this server has started simulating. That's the word. Simulating that virtual environment. Okay, so one person starts playing a game, the server spins up, starts simulating that virtual environment. Another person logs in, and they are logging in to that server, which is already running the virtual environment. Okay, so one person starts it all up, and they are in that game world with the server updating that virtual environment. Another person joins, the server's already up and running. Next, so they are just jumping into the same game. Another person joins into the same game. Another person joins into the same game. Another person joins into the same game. So if we want to give people roles, we need to do it when they arrive in the game. This is why I'm starting my flowchart when a user logs in. It's basically when someone starts playing the game or when someone joins a game. Then what we want to do, we need, how many roles for this one? We've got 2 roles. One role where it's ability to open doors and one role where it's ability to interact with sundial. So one person can interact with doors, one person can interact with a sundial. So when a user logs in, firstly, let's check if we've got anyone that can interact with doors. Is there anyone? Is there already a user who... Let's give them names, because this is going to get confusing. We've got doorman or door person. Sorry. Door person and sundialer. It's already a door person. And that is a diamond shape because it's a decision. And we've got two possible things. No. And yes. If there is not already a door person, make this user a door person. Bink. That is a process. If there is not, if there's not already a door person, make this user a door person. If there is there already a sundialer? Question mark. That's a word I've just made up to represent the people that can do the sundial. And surprise, surprise, we have a yes arm and a no arm. If there is already a door person and there's already a sundialer, this person is lucky. They don't have to do anything. End. I was going to do something funny and then I decided to just, let's not confuse the situation anymore. If there is not, make this person a sundialer. So we're divvying out roles, and we're going to, remember, we're writing instructions. We're writing instructions so that the computer can do this when we're not there. If this was a board game and I was the games master, I'd be explaining the rules to everyone, and then I'd be handing out roles. Oh, you're the banker, you're the door person, you're the sundialer, and so on, right? Or we'd vote on it like a good democratic situation, and different people would be assigned roles. Now, this is a computer game, so the computer does that assigning of the roles. Unless we wanted to build in some kind of crazy democratic voting system to, do that, we don't need to. For now, when a user logs in, check if there's a door person. If there isn't, make this person a door person. If there is, check that if there's a sundialer. If there isn't, make this person a sundialer. If there is, don't worry about it. They're along for the ride. Cool. So that's our problem broken down. And now we've broken that down, we can, into these logical steps, we can solve this. This is solvable. Let's do it. Okay, so what do we need to do? Well, we need a function that is, we need to handle an event. When a user logs in, we need to run some code, basically. How do we do that? It's actually not that difficult, fortunately. Let's right click the root object. So this, the ground, essentially. Let's add a locator. This is going to be role assignment. And I'm just adding it as a locator just to attempt to keep things organized. It's not organized. But this code will be added to this locator. Entity add script on the locator, new script, role assigner script. So this entity is a locator and it has a role assigner script. Okay. So we need to run we need to handle an event called when user logs in. Is there such an event? Let's look here. User login. Oh, I wonder if there's an entry point called yeah, there is. On user login. Entry points, they're always a good place to check. If you need to start from an event, then you don't know if it exists, check the entry points on the script function. Script, scroll down to entry points. And these are all the different events that will automatically fire in the game. And as long as you call a function one of these, then it will run when this event occurs, depending on if it's attached to players and the game and all that sort of stuff. But OnUserLogin is an entry point to a script. So instead of init, we'll do OnUserLogin, called when a new user joins the game. So when a user logs in, tick, let's get blue, tick. Is there already a door person? Okay, well, how do we check that? Well, it seems to me like we need to keep track of whether someone has joined before or whether someone is a door person. So maybe what we need to do is check, similar to how we did that here, if self.active is nil. If self.doorperson is equal to nil, then we don't have one. Else, then self.doorperson is equal to the user that just logged in. Do we get the user? Can we capture the user here? Yes. OnUserLogin, user. So if we put user here, that will capture whoever just logged in. User. Otherwise, now hang on a second, we haven't quite finished that, but let's go through this logic. If there already is one, so we're now in the else part here, there is already a door person. The door person is not nil. So is there already a sundialer? Okay, let's check that. If self.sundialer is equal to nil, then we know there isn't a sundialer. Self.sundialer is equal to the user. So firstly, grab hold of the user that logs in. The first user that logs in, they go in the self.doorperson. Then grab the next person, they go in the sundialer. Everyone else just gets ignored. So far, so good. Another thing we need to do here is tell the user what they are. We don't need to actually tell the actual user. That could just be part of the puzzle. But we need the user to know what they are, because in a minute, when we interact with things like the door script, we need to know whether this user is a door person or not. So let's create child. So now what we're going to do is go to the user template. So this is our little template drop down, and you can see these templates also in this template part here of the template part of the library. And what we need to do is we need to add a script to the user that's going to hold on to that information. It's going to hold on to whether the user is a door person or a sundialer. And I'm going to do that in a really organized way for once. I'm going to click on the user, add a script folder, and this is going to be called my role. And I'm just going to add one script to this role, and this is going to be called my user role script. I'm using user as the first part because that's a convention. User role script. You'll see other scripts have got user. Oh, none of the other ones do. Anyway, you'll see other scripts have user at the start when they need to be assigned to a user. Okay, user role script. Let's edit that. And this isn't going to have anything like that. This is literally just going to store data. So here, we are going to have a property. That's what we need. We're going to store some data, and the property is going to be name equals role. Type is a string. Okay. Do we want to give them a string like this? No. We want the computer to do that. We don't want to accidentally write in there. So we can actually do editable equals false as an attribute here. and then we won't be able to see that. So it's a good way to hide properties that you don't want there. You want to just manage behind the scenes like this. And I'm doing it as a property here because we're not doing anything in this script with it at runtime. We're using it as a we need to be able to refer to it from other scripts. So it's like a public property. It's outward facing. It's not editable in the editor, but it's outward facing and editable by other scripts in the game. Hopefully that makes sense. How much longer time is there? As in, how much longer are you going to talk for, Andy? I think 10 minutes. 10 minutes to finish this. Okay. So we're going to send this to that user. So user, send to user. Yeah, send to scripts. We're going to call an update role function, and we are going to send through the string door person as our role. And here, we're going to update role, and we're going to send through sundialer. Here, update role is a function. We need to now capture user role script function, user role script. Update role, new role. Actually, let's just call that role. And self.properties.role equals role. So when a user logs in, store that we've got a door person and send that the user in control of that character, the update role event, and the string door person, which then gets stored in there. And then if we already have a door person, check if we have a sundialer. And if we do not have a sundialer, store that we now have one and send the sundialer role and store it in here. Now on door script, we want to check whether this person can actually open this door. This function is called on the server when this entity is created. No, it's not. That's a lie. Open door, that is for the door person. Open door is called, let's find out. When is open door called? When we interact with this pedestal, we call open door. And if we remember, that will pass through the player that did that interact event. So let's capture the player. Let's test. Else if, let's test whether player find script property role. So that will find, look, search for all of the scripts that are added to the player. We want to search all the scripts that are added to the user. Remember, we've got a player, which is the character, and we've got the user, who's the person controlling that character. Find any script property attached to the user, and the script property has the name role, and this script property has the name role. Check if that is equal to door person. If it is, then open, says to me. Another way we could do that, yeah, no, that works. Another way we could do that is we could do, there's lots of ways we could do this. Another way is if we are not equal to that, then return. Remember using that return thing that we did earlier? So if the player is not equal to, that's what that means, not equal to a door person, then escape. Don't run the rest of the code. Yeah. Okay. The other one was the sundial. Here. If is server, fine. Do all of this stuff. Yeah. Change time of day. We need to test before we even do that. If player get user find script property role is equal to sundialer, then. If it's not equal to sundialer, then return. And don't run the rest of the function. So we're basically doing really similar things here. We've got door script, which is saying if it's not a door person, then don't run the rest of this function. And we're saying if it's not a sundialer, which is attached to, which is in the script that's attached to the sundial, then return here. Let's give that a whirl. And I don't know who's who. Let's go and find out. Am I allowed to open the door? So I should be able to unlock it regardless. Let's try running this. Okay, so I'm going to need to try the other computer. Hang on a sec. It worked! Yay! So that means... Oh god, that made me jump. Woo! That was the intention. Let's now try this with this character. Hey! So now I have roles. So only one person can open the door and one person can, and someone else can be in control of sundials. So that answers that question. And it's a really fun thing to do with puzzlers like this, especially group puzzlers. Hand out specific roles and then explore that mechanic deeply. So if you've got a door person that can open and close doors, what happens when they're not around? You know, what happens when they are around? Does it make things easier? Does it make things harder? Does it change the route that your little band of players can take? All of that stuff is now possible now that you've got to grips with the understanding of servers and clients. Because now that we understand we've got the server-client relationship and we know that each client is a player running on their computer in their house and they're communicating with a central server that's running this game. When we run an event that's hooked up using our binding system like this, any bound things like this, they run on the server by default. They don't run on the clients. So we can put in a little test and we can say, is this a server? If this is currently running on a server, then run this on a client and return. So don't run any more of this function. If this is not a server, this gets ignored and we can crack on. We can do some cool stuff. We can change the world. We can hand this player a gun. We can turn on some lights, turn off some lights, make floor disappear, turn on some collisions, all sorts of stuff. We could change roles at that point. What if you interact with a button and it swaps roles with someone else? All of that's now possible now that we've got the understanding of using is server and is client, or send to all clients with the name of a function, and we can then test whether which client is which. An even better way to do this, have I got time? Yeah, another way to do this is on a player. We can create a little run on client. Let's just do client only. Script folder. Let's add a script in there. Client only script. And another way to do this would be to, when we do this, rather than here, rather than this, we can go client send to scripts. Send to local. There's a better way to do it. And we will explore that next time. I'm running out of time. So I'm going to call it there. But there's a nice way you can hook this up. And I will look at that with you in the future, where you can essentially send an event to a script attached to just the player and then basically call back this function, but only on the player. And it's a tidier way to do it. It's not essential, though. It's just one other way to expand upon this. This will serve you just fine for now, using our little if statement here to interrogate who this client is and whether they're the right client, whether they're the right user. Hopefully this has been an interesting and useful tutorial. Una F, Big Tens, thanks for that. This is server and client relationship, and I know some people might find this quite straightforward. Some people might find this horrendously complex. Let me know in the comments below if you have any further questions. Don't forget to like and subscribe our YouTube and Twitch channels. If you've got any issues with what we've covered today, head over to our Discord, discord.gg/Crayta, and you can ask if you've got problems with the code. You can ask in the Lua help channel. If you've got just general questions about Crayta, head over to Ask Anything. You can ask in there. I will now push an update for this. So let's go to Create. Let's go to Scripting for Beginners. Publish update. I'll leave all of this the same. So that game is now updated, which means you can go and remix. You can take a look at what we've done today in a little bit more depth. You can grab any code, copy and paste it, put it in your own game. You can take that game and turn it into something cooler than it is. Maybe with a little bit more depth, a bit more story, some cool mechanics. It's really up to you. There is, as I've said before, there is all of the obby stuff in here. Somewhere. Let's try and find it. Is it down here? Yep. So it is an obstacle course game from that template. And I haven't changed any of that stuff. So if you look for terrain, and then you've got all of the equipment you need to make an obstacle course here. Some checkpoints, some deathly objects that will kill you if you touch them. Your player's got all their health and everything all set up already. So that's something that you might want to do. You might want to take this and create an obstacle course. Maybe make different obstacles for different roles. Who knows? Thank you very much, Andy. No problem at all. It's always a pleasure. We'll be placing all the Scripting for Beginners vid in our Pack Crayta server. Great stuff. Yeah, it was a bit of like a long-winded approach. I think it was a bit of a long-winded approach for quite a small amount of content, but I really wanted to make sure that I didn't confuse anyone. And just at the end there, I think I started to get a bit confusing. That's something I need to think about for the future. But hopefully it's been interesting. I quite like this idea of, you know, using prompts around the world, interacting with prompts around the world to change what, you know, the whole world, especially with the theme of like ancient civilization with kind of magic, but maybe we don't really understand, because that's quite cool, that theme. So that's quite fun. Anyway, maybe something to think about. Yeah, if you don't know, there's a battle pass coming out this week, and that is something super exciting to get excited about. I'm excited about it. Russ will be streaming tomorrow, and AJ will be streaming on Wednesday, and then there'll be a tutorial coming out on Thursday, and got a workshop on Thursday as well. So if you liked learning like this, or if you didn't like learning like this and want to learn more in a small group where I take the group through probably more like a creative problem, and we jam ideas and work together to make something interesting and funky, then that is a cool place to learn some game dev as well. I'll try and reinforce what I'm doing in the streams in those sessions too, so that they link up a bit nicer. That's something to look forward to. Let me know if you've got any comments or questions. It's been great. I always love streaming, and I always find that it's such a lovely audience, and yeah, some great questions, always really interesting. I really like the role stuff that we did at the end there. So thanks for asking that question. That's it for this week, and I will see you next week for some more game dev learning stuff. Ta-ta for now. Have a good week.